Wetland hydroperiod change along the Upper Columbia River floodplain, Canada, 1984 to 2019, by Chris Hopkinson, Brendan Fuoco, Travis Grant, Susan Bailey, Brian Briscoe, and Ryan MacDonald. Increasing air temperatures and changing hydrological conditions in the mountainous Kootenay region of British Columbia, Canada, are expected to affect floodplain wetland extent and function along the Columbia River. The objective of this study was to determine the seasonally inundated hydroperiod for a 29 km² section of the Upper Columbia River floodplain wetlands complex using time series satellite image observations and binary open water mask extraction. A mid-pixel resolution of 30-meter optical satellite image time series of 61 clear sky scenes from the Landsat thematic mapper and operational land imager sensors were used to map temporal variations in floodplain open water wetland extent during the April to October hydrologically active season from 1984 to 2019. The hydro period from the first 31 scenes, or 18 years, was compared to the second 30 scenes, or 16 years, to identify changes in the permanent and seasonal open water bodies. The seasonal variation in open water extent and duration was similar across the two time periods, but the permanent water body extent diminished by 16%, or 3.5% of the total floodplain area. A simple linear model predicted floodplain open water extent as a function of river discharge downstream of the case study area. 4 years of Landsat multispectral scanner data from 92 to 95 were examined to evaluate the feasibility of extending the hydroperiod record back to 1972 using the lower 60-meter resolution archive. While the MSS hydroperiod produced a similar pattern of open water area to duration to the TM-OLI hydroperiod, small open water features were omitted or expanded due to the lower resolution. RadarSat-2 scenes from 2015 to 2019 were examined to evaluate the feasibility of continued mountain valley hydroperiod monitoring using the higher spatial and temporal resolution sources like the RadarSat Constellation mission. From the available horizontal transmit-receive, or HH, single polarization sample set, the hydroperiod pattern of open water extent to duration was similar to the longer Landsat time series and possessed greater feature detail. But it was significantly reduced in seasonal inundation area due to the systematic omission of open water areas containing emergent vegetation. However, accepting that differences exist in sensor-based hydroperiod attributes, the higher temporal resolution of RadarSat Constellation mission is suited to mountain floodplain inundation monitoring and open water hydroperiod analysis. We wish to acknowledge the Columbia Wetlands Stewardship Partnership and the Natural Sciences and Engineering Research Council for funding this research. We would also like to thank the United States Geological Survey, the Canada Centre for Mapping and Earth Observation, the Province of British Columbia, and Environment Climate Change Canada for providing data.